Okay, welcome. Today we are focusing on the quadratic formula and a specific part of it, which is the discriminant. So the quadratic formula is a method of solving quadratic equations that can be used to find exact solutions. So the solutions of any quadratic formula of the form ax squared plus bx plus c equals 0 can be found by plugging the coefficients of a, b, and c into that equation. So it's really important, and it's hard learning through this to not memorize this, but didn't mean to do that. C is there, A is purple. But the quadratic formula is a concept and formula that's used through the rest of your high school math career. And so we really need you to memorize this. But today, we're going to focus on the discriminant piece. So hopefully you remember that the discriminant is b squared minus 4ac. Okay. And so it's got a special name. It's called the discriminant. Okay, and this number, so again, b squared minus 4ac, when I input numbers, I'm going to get an output. It's going to be a number, okay, and it's going to determine the number and type of solution. So sometimes that number, so when I calculate it, it's less than 0, okay, so a negative number. If my discriminant is negative, it means that I'm going to have 0 real solution. So for example, I calculate it and b squared minus 4ac equals negative 5. Then we would know that there's 0 real solutions. Which also means, just keep in mind, that means there's 2 imaginary. But remember, that's a concept that we don't learn in Algebra 1. We may calculate the discriminant b squared minus 4ac and it equals exactly 0. That means there's going to be 1 real solution because it's a double root. So remember what a double root looks like? That means, we have our vertex on the x-axis, right? If we were visually thinking about it. So again, if our discriminant equals 0 exactly, that means there's 1 real solution, a double root, and we're going to list it twice. If my discriminant, I calculated, I input some numbers, I get my output, and it's greater than 0, that means there are exactly 2 real solutions. So maybe I calculate my b squared minus 4ac and it equals 12, right? That's going to tell me it's a positive number, right? So again, this is positive. This means a negative number. That means there's going to be 2 real solutions or 2 x-intercepts. So I'm going to actually sketch this down here. Again, big idea. So I'm going to calculate a discriminant that's positive. Oops, I'll do a negative. Well, we'll do positive. So if my discriminant is positive, that means I'm going to have 2 real solutions, meaning I'm going to have 2 x-intercepts, right? So this is 2 real solutions, which equals 2 x-intercepts, right? Again, we talked about if my discriminant was actually 0, right? That means I'm going to have 1 real solution. And for example, I may have my vertex here, okay? So 1 real solution, double root, meaning we list it twice, means I'm going to have 1 x-intercept, and you can probably make some conjectures by now. If I have a negative discriminant, and that means I have 0 real solution, meaning I have 0 x-intercepts. Or above, if my discriminant is negative, which is this top situation right here, this tells me there's exactly 0 real. So I'm going to go back here. It's positive, meaning there's going to be 2 real solutions. Oops. Okay, so the first example says find the value of the discriminant. So when I read that, again, discriminant is defined as b squared minus 4ac. It's part of the quadratic formula. And we're always going to calculate this first. And so that's why today is focusing on this one calculation. And then we're going to state the number. So 0, 1, or 2, and type of solution. So there always will be real solutions. Okay, and so I'm going to walk through the first one and explain how I would process this, and then I'll let you practice. Okay, so first of all, I think it's really important when I look at this is to first define A, B, and C. So A is 2, B is 6, and C is 5. So I'm going to always calculate this first. So B squared minus 4AC. You'll notice I did put these parentheses around the 4AC on first, or I put the parentheses around 4AC because it's really important to help with our calculations. We won't get mixed up on negative signs. So we're just going to input the numbers. So B in this problem is 6. So we're going to have 6 squared minus 4 times A times C. So I'm going to get 36 minus, what's 8 times 5? 40. And that's negative 4. Okay, so that's my discriminant. And then we want to know, what does it mean? So if we go back, so the conclusion we would draw is 0 real solutions. Okay, I'll do the next one and then I'll let you try the next few. I'm going to erase this. Or not. Okay, so let's do this. A is 1. B is negative 4, and C is negative 2. So to calculate the discriminant, B squared minus 4AC. Okay, so we have B squared. So make sure we put the negative 4 squared in parentheses. Really important that we use parentheses. If not, you're going to have an error. Minus 4 times A times C. So we get 16 minus negative 8, which is going to equal positive 24. Now what's important is you can type this, I'll do the green, into your calculator just like that, and it will give you the correct answer. The key is making sure we put parentheses around any negative numbers right here and right there in yellow. Okay, and so we get 24. So what does that mean? Okay, it's positive, right? So your final answer, so again, my discriminant is 24, okay, and then we would say 2 real solutions. Okay, so we have 2 other examples to you. So what I would like you to do is to pause the video, try and calculate the discriminant, and name the number and type of solutions, and unpause when you're ready to check. So for C, you should have gotten a discriminant of 0, which tells us we'd have 1 real solution. It'd be a double root. And for D, I got negative 20, which tells me, because it's negative, I'd have 0 real solutions. You can always write 2 imaginary if you want, because again, we know all quadratics have 2 solutions. But in this case, in Algebra 1, we're only focusing on real solutions. So why do we calculate the discriminant, right? I think that's a really important question. The discriminant's helpful because it helps us get started on the quadratic formula, and it tells us what type of solutions I'm going to find. And so if you remember back to our first example on the warm-up, it said find the exact solutions of x squared plus 2x minus 2. And we had a problem because we didn't know how to do this. Factoring, graphing, and inverse operations didn't work. And so our resulting option is the quadratic formula, okay? And so if we go back and we look at the graph, we know the decimal approximations are x equals negative 2.732 and 0.732. But remember, we want exact solutions. Notice it's even highlighted right here, right? And so the quadratic formula is going to help us find the exact solutions, okay? Which will match the decimal approximations when we simplify it. So we're going to use the quadratic formula for the very first time. I wish I was with you doing this. This is very exciting. This is a big day. So first thing we're going to do is we're always going to start by calculating our discriminant. Okay, so we're always going to start with underneath the radical, and we're going to calculate whatever b squared minus 4ac equals. Okay, so we're going to do that, and so b is 2. A is 1, negative 2. So remember, you can type it in your calculator exactly as you see it there. When I do that, I'm going to get 4 plus 8, which is going to be 12. Okay, and so I get a discriminant of 12. So what that tells me is it's positive. So I have 2 real solutions. So I need to find them. I can keep going. Okay, so the next thing we're going to do is we're going to plug everything into the formula. Okay, so I have x equals opposite of b. So b is 2, so opposite is negative 2 plus or minus the square root of b squared minus 4ac. But what do I know the b squared minus 4ac to be? It's my discriminant, which is 12, so we can plug it in right there. All over 2a. Okay, so we're going to plug it in the formula. Then step 3 is we're going to simplify the radical if we can. Okay, and so when I look at the radical, I have square root of 12, and I think we all by now, oops, I don't want to use that color. We're going to pick a different color. I think we know we can simplify square root of 12. Okay, and so we know square root of 12 can be rewritten as 2 root 3. So we simplify the radical to 2 root 3, and then we're going to plug it back in. So I have x equals opposite of b plus or minus. Now instead of root 12, we're going to write 2 root 3. Okay. All over 2a. Okay. Oops, 2a. We know that value. Didn't mean to do that. We know it's 2, right? Because 2 times 1 is 2. So then our very last step is we're going to ask ourselves, can I simplify the constant? So we'll go step 5. I always do that. Okay. So what I mean by constants is the 2, 2, and 2. Can I simplify those? Okay, and I think you asked, and by simplify we mean reduce, right? And hopefully we're all like, yeah, we can do that. And so what we're going to do is they're all divisible by 2. So that's going to become 2 divided by 1, 1, 1. And so our final answer will be x equals negative 1 plus or minus 1 root 3 all over 1. Okay, and we don't need this denominator anymore, so you'll see the final answer like this. Negative 1 plus or minus square root of 3 is our exact solution. So the exact answers are x equals negative 1 plus or minus square root of 3. So here's the connection, and here's the big idea. If I were to type negative 1 plus square root of 3, I'm going to get the 0.732. And in my calculator, if I were to type negative 1 minus square root of 3, I'm going to get negative 2.732. Again, those match, but again, we want the exact answers, and that's what the quadratic formula does for us. Now, walking out of class today or finishing this video, you should feel confident calculating the value of the discriminant, which is b squared minus 4ac, and then naming the type of solution, number and type of solution. So you just got a preview of the quadratic formula, and that's what we'll spend a lot of time on in the next few days. Okay? And we're also going to summarize why we love the quadratic formula. So, big idea. Does factoring always work? Hopefully you say, no, it doesn't always work. Does the quadratic formula always work in the correct answers? Yes, it's always going to give us our exact answers. Does solving using the graphing calculator always work? Yeah, it does, but what's the problem with solving with the graphing calculator? And sometimes there's not always exact solutions, and that's what's sad about this. And so it's really, really important that you understand that moving forward, we're going to be finding exact solutions. We can use our graphs to double check our solutions, but we cannot, on our tests or any assessments moving forward, just list the decimal approximations. Okay? So again, big idea, you should tell me you know the discriminant is b squared minus 4ac. If it's positive, you know there's two real solutions. If it equals 0, you know there's one real solution. It's a double root. And if it's a negative discriminant, you know there's 0 real solutions. So that is where you should be for today.